Hello, we're Team 6, and we're here to talk about technology, the answer to enabling highly efficient healthcare organizations. Myself, Nick Cruz, Erica Benston, and MD Islam. Each of us will cover a topic on making a healthcare organization efficient and some of the new technologies that are available. Our topics are the electronic medical record, telemedicine, advanced diagnostics.
Now you may ask why my part of the presentation is different from the rest of my team. Well, I'm actually in my doctor's office. They wouldn't let me in their file room to show you their rows and rows of medical records, but at least they were nice enough to let me sit here and shoot my part of the project. Here are a few reasons why EMRs would be effective to physicians' office. Number one, it would create a paperless environment. There'll no longer be a need for a file room or a person to go and pull medical records. Everything will be available at the doctor's hand by just a click of a button. Number two, it reduces HIPAA violations. How many times have you walked into your physician's office or a doctor's office and you've seen other people's medical records there? Those medical records contain PHI, which is protected health information, such as the patient's name, their social security number, their address, any personal information, their diagnosis, why they're being seen. All of that information is housed in that medical record. How would you feel if your medical record was just left out for anybody to see? Me, personally, that's very unsettling, and I wouldn't be happy at all. Another reason, the information would be available there real time. The doctor wouldn't have to call, do a consult with another doctor that you saw 5 months ago. Again, all that information right there at the click of a button, he has that information. Another reason why EMR would be a great technology to enable a healthcare organization, it would give the physician more time with the patient. How many times have you been in a treatment room with your doctor for he or she to spend maybe 5 minutes examining you, but the next 10 minutes writing your medical chart? Well, with EMR systems, that would be alleviated. The doctor would speak into a tiny microphone and have that dictation automatically transcribed for him, giving he or she more time to actually spend with you, talking to you to get the correct diagnosis, to get the course of treatment, to treat whatever you're going through, or to help get you well, because that's the reason why we go to the doctors. Another reason, it would help lower healthcare costs. Insurance companies pay millions and millions of dollars each year on unwarranted and unneeded medical procedures. The less claims the insurance companies pay out, the lower our premiums. The lower our premiums, the less money we have to pay out. It means more money in the pocket. For me, that just means more shopping. And with that, I'll go ahead and turn it over to Ed, who's going to speak about telemedicine.
Our next topic, remote presence, virtual and independent telemedicine assistant. Basically, it's a robot. The manufacturers of iRobot and a common medical telemedicine application have gotten together and created a self-navigating instrument that moves throughout the hospital and allows collaboration between the patient and a remote location. The console allows for collaboration and linking in other departments. You can link in the lab department, you can link in a family care physician, all in the video display with none of the physicians actually being present except for the hospitalist and nurse at the facility that are using the instruments attached to the robot to provide services to the customer. It has several extensible features, attachments like oscilloscopes and ultrasound stethoscopes, and passed FDA clinical trials January of this year. The cost for the unit is a service-based fee, $4,000 to $6,000 a month, covers the cost of the equipment as well as the service.
The company that brought you the Roomba and other robots to clean your house may soon be making your doctor. The FDA has approved iRobot's RP Vita for use in hospitals, meaning the RoboDoc could start showing up in the ward by the next time you're admitted. Of course, the RP Vita isn't going to be treating you on its own. Think of it more as a way to teleconference with your doctor, no matter where he or she is.
RP Vita will access patient data, notify the doctor to join in, and provide them with the informatics they need to perform a complete patient evaluation.
The Boston Herald's BizSmart notes the biggest accomplishment is the fact that the robots do not need first-hand assistance. iRobot Chairman and CEO Colin Angle says the major breakthrough is the fact that these robots can bring themselves to where they're needed. No robot has ever been approved to navigate through hospitals before the telemedicine. And Engadget reports RP Vita is a lot more intelligent than one might think. It has more medical expertise than some humans have. The RP Vita should prove nimble enough for medical triage with obstacle detection and avoidance baked into the mechanical pillar. RP Vita will cost between $4,000 and $6,000 and are expected to be shipped this spring. For Newsy, I'm Candace Avilés, Multiple Sources, The Real Story.
It increases collaboration, reduces physician response times, enables accessibility to remote locations, and reduces the costs. And now I'd like to turn it over to MD to talk about the microfluid.
Hi, my name is MD. Today I'm going to present one important biotechnological invention which is called a microfluidic chip, and this is the advanced diagnostics for the diagnostic of flu. We all know that in 2009 there is a lot of death in all over the United States and all over the world, and there's a statistics in CDC report which called like 6,000 deaths in 2009 by the H1N1 viruses, and all over the world, even in 214 countries, like 18,000 deaths. So why the lot of death? If we go through these, so we can find it that poor diagnosis report, longer diagnosis report, and there is a traditional based diagnosis available on that time. So we can imagine a specific situation like a children go to a hospital in an emergency room with an infected influenza. Then the doctor prescribed him some laboratory test, and then he diagnoses after the laboratory test what kind of influenza it is. So all of this process taking longer, then the doctor prescribed him some medications. So this is the longer process that each and every hospitals or diagnostic center need. So researcher in Boston University and also Beth Israel Diagnosis Medical Center and Harvard University, they actually invented a microfluidic chip which decreased all the time and also the cost of this diagnosis process. Let me talk about how it works. So there is a microfluidic chip which is a microscope size, and it consists of a column. There is a 3 separate type of column on that, and these columns separate RNA from protein, and then it separate DNA from the RNA. Then a climate control lower channel used to replicate the DNA to sufficient quantities to be detected by the external reader. So look, we can look at the facts about the microfluidic chip. So it can be used in different, it can replaced on different traditional diagnosis. We can see the viral culture, rapid immunoassays, direct fluorescent antigen testing, which is called DFA, and RT-PCR. So these are the traditional versions. So in terms of the turnaround time, in terms of the sensitivity, and in terms of the easy of use. So all these microfluidic chip can replace all these diagnoses. And so we can find the benefits of this. We see the lower fabrication cost and also the fastest result. That means all these longer processing time, the microfluidic chip making it a shorter result. And there's a reduced cost because it's a disposable chip and easy to use, easy to find, and less technician time. No need of specialized facilities. So researchers, they invented a duct so you can easily separate fluids, so you can easily maintain the temperature, you can easily make all processes. And finally, we can go the advanced level of the microfluidic chip, I mean future of the microfluidic chip uses. So for the stem cells outbreaks, microfluidic chip can still be, I mean, very good future in that. And for the amplification of influenza and diagnosis, even with the HIV infection, and obviously DNA separation. So we can find that all these uses and all these applications are made easy by the microfluidic chip, which is cheaper, which is lower in cost, and just definitely give you the fastest result. Next, I'm calling one of my mates, Nick Cruz.
Hi, I'm Nick, and as part of our topic here, I chose to cover one particular example of some new biotechnology, the skin cell gun, which skin spraying has been a technology that has been in use since early 2002, but the most advanced version of this has been seen over the past couple of years with Dr. Gerlach's new skin cell gun. And to briefly explain how it works, skin cells are extracted from healthy, undamaged skin, put into basically a solution of cells and water, and then when using the device to apply it, it's sprayed on damaged or burned skin. Okay, and to give an example of just the effectiveness of this device, here's a before and after picture of results after using this device. Just to kind of briefly go over some of the benefits that you see. In the past, you would have to use skin grafts to be able to achieve healing for burn victims or patients that have suffered any other traumatic injury to their skin. And the problem with that is that it could take up to weeks or months for those to be developed and then applied to the patients. The problem with that is patients are subject to infection, dehydration, and just a bevy of other issues during that recovery period. The benefit that we see with the skin cell gun, these patients were healed within a matter of days with no known side effects. And I mean, as you can see, you can't even tell that they ever even had a burn or any damage to begin with. It has been that effective. At the moment, it's still considered an experimental device because it can really only fully effectively treat second-degree burns. But at the same time, even though it can't fully heal third-degree burns yet, there is evidence that it can at least prevent infections. So clearly, there are a number of ways that it is increasing efficiency in healthcare, and eventually they do hope to get to a point where it can tackle all types of burns and other skin damage that we may see.
Skin is the largest organ in the body. And when it's severely burned, it needs to be replaced quickly and massively.
The standard techniques that we have now, that takes weeks, months, sometimes. And the reason why people die is because of infections that develop while we're waiting for the skin to heal.
How are you doing pain-wise?
Pretty good.
Okay.
So if we could find a way to get normal, healthy skin, as much of it as we want, within a week, that's the holy grail in burn surgery.
George Gerlach thinks he's found a way. but he'll need a gun.
We call it a skin cell gun, a device for the deposition of skin cells onto the wound.
It looked like something you'd see in Star Wars.
This is Matt Urim, state police officer from Pennsylvania. He's one of the first people to be treated with the gun.
I attended a July 5th party at a friend's house, and there was a small bonfire. I was standing next to the bonfire, and an individual decided to throw a cup of gasoline on the fire. The worst part was my face. It was the whole right side of my face here, my ear, my neck, and my shoulder, and the entire top part of my arm.
Urim had suffered severe second-degree burns. This photo shows what a second-degree burn looks like.
The arm kind of looked like a piece of charred meat, like a hot dog that was left on the grill too long. The doctor said that I might be a candidate for this new procedure, which is the spray gun, and asked me if I would be interested.
Skin cell spraying is like paint spraying, just you need a more sophisticated device, like computer-controlled. We isolate cells from the healthy part of the skin, the patient's own cells, which can be taken in a water solution, and that solution is prepared for cell spraying.
Basically, what they were doing was taking my stem cells from my skin and putting them all in the gun and spraying it on my arm.
Scientists have been able to regenerate sheets of skin for decades. The problem is it takes weeks for that skin to grow, and the new skin is extremely fragile. Gerlach's gun solves both of these problems.
It takes like 1.5 hours to take the biopsy, to isolate the cells, and to spray the cells.
This is what Urim's skin probably looked like before treatment. This is what it looked like 4 days after it was sprayed with his own stem cells.
They did it on a Friday, and my follow-up was that Monday, and the burn unit said it was healed, completely healed.
Though the skin gun is still experimental, over a dozen patients have already been successfully treated.
And with that said, I'm going to turn it over to Ed to close us out.
Thank you, Nick. The next thing I'd like to cover is our summary. We believe EMR is poised to provide efficient, accessible information in the future. Telemedicine will provide an efficient means of access to specialized care through remote consultation with physicians. Advanced diagnostics will become cheaper and faster, and new technologies such as the skin cell gun are only but one of the many options that will reduce the overall recovery time available to future patients. And as our final slide, economics. We see that the marginal cost and the supply line average cost with a technology shift lowers the break-even point, as well as increases the availability of products to make the process more efficient, and we believe technology will help as part of the solution to the current healthcare crisis. Our citations. Thank you very much.